To find average rate of change of a graph, we have our formula here. F of b minus f of a. F of b just represents the y value at x equals b, and f of a the y value at x equals a. We find the difference between these two y values, and then we divide by the difference between their respective x values. Notice it wouldn't matter which way you did that. You could also do f of a minus f of b, as long as your bottom changed the order as well and you had a minus b. And a and b, they're just two x values for the function, and that's just the interval that we're finding the slope over. If that looks familiar to you, maybe it reminds you of your y2 minus y1 over x2 minus x1, which might be how you would have seen it more in Algebra 1. We'll work some examples, but just to process the steps that you need to take to calculate the average rate of change, the first thing you want to do is look at the interval that the problem gives you. So you're getting two x values. We need to plug those x values into the function to find their y values. Or if you're given a table or a graph, read the y values from the table or the graph. And then we can set up our f of b minus f of a over b minus a and actually calculate the average rate of change. All right, so let's work with this. So we have a function up here, g of x. That's totally okay. That just means that we're going to be finding g of, because the f in the formula we saw just represents the function's name. So now our function's name is g. We need to look at our interval. Our x values we're looking at from -2 to 3. Okay, so g of 3 minus g of -2 over 3 minus -2. And when we're given a graph, we're welcome to pull those values directly from the graph. So g of 3, we're looking at the y value when x equals 3, and it's 1/2, 0.5 there. So 0.5 minus, and then g of -2, when I go to -2, the y value is -2. So 0.5 minus -2 over, and I'll go ahead and simplify the denominator. 3 minus minus 2. Remember, when you subtract a negative, you're really adding. So that would be 3 plus 2, which is 5. All right, same thing in the numerator. 1/2 minus -2 is really adding. 1/2 plus 2, so that would be 2.5 over 5. And if I wanted to reduce this, I absolutely could. 2.5 is half of 5, so I can reduce that fraction to 1 over 2. All right, so think about this graph, and remember in Algebra 1 you spent a lot of time working with linear functions. Will the average rate of change always be 1/2? And the answer to that is yes. So that's true for any line. The slope is always going to be the same along the line. So remember, rise over run, we go up 1 over 2, up 1 over 2. So a slope of 1/2 isn't unique just between this interval. It's true all the way throughout the line. Another example here, and again we're given the graph. And now we want to work with the function where it's just f of x equals 1. And we're working over the interval -2 to 3. So to set that up, I'd want to find f of 3 minus f of -2 over 3 minus -2. And f of 3, I can look at the graph there. The y value is 1. F of -2, the y value is 1. 3 minus -2, that's like 3 plus 2. Simplifying this, 1 minus 1 is 0. All right, so think about this. We have 0 over 5. That's really the same thing as 0. And let this make sense to you. We have a line that's just flat. So our line is constantly 1. So we have a constant slope of 0. So it's not surprising to us here. If you're thinking about rise over run, there is no there is no rise on this graph, it's just flat. So this slope will always be 0. Again, it's another line, the slope is always the same. And because it's a perfectly horizontal line, our slope is just 0. So the process is going to work the exact same if you are not given a graph to look at. So notice here, we're given this absolute value graph. So I'm going to replace y with f of x so we can use our function notation. So we have the absolute value of x plus 2, and we're given 2 intervals to calculate here. And what we need to do is we need to find f of 0 and f of negative 2 for the first problem, which we can absolutely do if we go and plug those into the function. So if I want to off to the side, just to keep it straight, of x, I'm making a little table. And the x values of interest, I definitely need to know negative 2. That's used in A and B. And I'm also curious about when x is 0 and when x is 3. All right, plugging those into the function, I literally replace the x right here with those values. So I'm going to have the absolute value of negative 2 plus that positive 2. Now go ahead and clean that up. So when we plug in negative 2 into the absolute value, it's the same as positive 2. 2 plus 2, that would be 4. So f of negative 2 equals 4. I'll switch colors. Plugging 0 in, we have the absolute value of 0, which is 0, plus 2. All right, that's just positive 2. And then plugging in 3, the absolute value of 3 is 3 plus 2, that's the same thing as 5. So now we can use those values, we've made this table, to make our calculation of our average rate of change a little bit easier. One term I haven't mentioned yet, one thing that we call this formula is the difference quotient. Difference because we're subtracting, quotient because we're dividing. So you might hear me use that term again. So for the first one, f of 0, that was 2. F of negative 2, 4, over 0 minus minus 2, so 0 plus 2. And that looks like 2 minus 4, negative 2, divided by 2, equals minus 1 for our average rate of change. And then for part B, f of 3 was 5. F of negative 2 was 4. And 3 minus minus 2, that's 5. So 1